The Nobel Prize is the epitome of scientific achievement. And every year we look forward to who is going to get it this time. And of course, I'm especially interested in the chemistry Nobel Prize. Professors Benjamin List of the Max Planck Institute in Germany and David McCallum of Princeton University were the awardees this year for organocatalysis. Now, that probably doesn't mean very much to you, but I can tell you this is a very important concept in chemistry. You know what catalysts are? These are substances that speed up a chemical reaction. They do not take any part themselves, that is, they don't get used up during the reaction, but they make the reaction go faster. Let me give you an example of a catalyst. What I have in here is hydrogen peroxide, H2O2. It easily breaks down to H2O and O2, water and oxygen. That's happening right now, but it's happening very, very slowly. But if I add a little metallic catalyst, look what happens. That reaction speeds up. You already see the boiling here because it's an exothermic reaction. A lot of heat is generated. So the peroxide is being broken down into water, and because of the heat, the water changes into steam, and you see the steam evolving here. The oxygen, of course, is invisible. But look how this reaction now has been speeded up. And that's what a catalyst can do. And you see the vigorous reaction now, a lot of heat being produced, and you see the steam coming out. Now that's a catalytic reaction. The catalyst I used here is a metallic catalyst. It's actually manganese dioxide. And catalysts are used in industry all the time to speed up chemical reactions. For example, the glasses that I'm wearing here, these are made of polycarbonate. When you make this in the laboratory, you have to join together small molecules to make this plastic. That requires a catalyst. The catalysts that are used are these metal catalysts. They're very difficult to use because they get basically corrupted if they are exposed to atmospheric conditions, like to a lot of oxygen. Very difficult to work with. Enzymes are catalysts that our body uses. These are very important. All the reactions that go on in our body all the time that constitute life require these enzymes, protein molecules. And they're very difficult to work with outside of the body because they only work at body temperature, essentially. Well, in this particular case, what the researchers discovered were very simple molecules, not metallic ones and not enzymes, that can act as catalysts. In the case of Professor List, for example, he wondered how enzymes work. Enzymes, of course, are long protein molecules made up of many amino acids. And he figured that these enzymes must work because of one or more particular amino acids in the right position in the molecule. And he found one amino acid, proline, a very simple molecule, no metal in here. This is nitrogen, carbon, hydrogen, and oxygen. Much simpler than an enzyme. It can carry on reactions outside of the body. This has consequences all over the place. For example, in the production of plastics, as I already mentioned, in the production of numerous items, rubber, for example, synthetic rubber is made by using catalysts. About 35% of all the consumer items that we ever encounter in the world are based upon catalysts. And if we can use cheaper catalysts, which organocatalysts actually are, which are more efficient, which organocatalysts are, which don't get easily contaminated, then of course we are on the right track. So certainly we can say that in this case, the two awardees, List and McCallum, were very, very deserving because we are already seeing the consequences of their research. And I'm very glad to see that they got the Nobel Prize for catalysis, a reaction that I've been performing as a demonstration for many years.